A black hole is a region of space where gravity is so intense that nothing, not even light, can escape from it. This makes black holes invisible, or black, since no light or any other radiation can get out to be detected. Black holes form when massive stars collapse under their own gravity at the end of their life cycle, though they can also form through other processes, like the merging of smaller black holes or large accumulations of matter. Key features of black holes: singularity. 1. At the very center of a black hole lies a point called the singularity, where the gravitational pull becomes infinite and the curvature of spacetime becomes infinitely steep. 1. This is a place where current physical laws, like Einstein's theory of general relativity, break down, and we don't have a full understanding of what happens here. Event horizon. 1. Surrounding the singularity is the event horizon, which is the point of no return. 1. Once something crosses this boundary, it cannot escape the black hole's gravitational pull, no matter how fast it tries to move, not even at the speed of light. 1. For an outside observer, the event horizon appears as the surface of the black hole. Gravitational time dilation. 1. As an object approaches a black hole, time appears to slow down relative to an outside observer. 1. This is due to the intense gravitational field, a phenomenon predicted by Einstein's theory of general relativity. 1. From the perspective of an outside observer, time for the infalling object appears to freeze at the event horizon, though the object itself would experience time normally as it crosses this boundary. Types of black holes. 1. Stellar black holes. These form when a massive star exhausts its nuclear fuel and collapses under its own gravity. 1. They typically have masses ranging from about 3 to 20 times the mass of the Sun. 2. Supermassive black holes. These are millions to billions of times the mass of the Sun and are found at the centers of most galaxies, including our own Milky Way. 2. The exact mechanism of how they form is still a topic of research, but they are thought to be essential in galaxy formation. 3. Intermediate black holes. Between stellar and supermassive, these have masses of a few hundred to a few thousand times the mass of the Sun. 3. There's evidence of their existence, but they are more elusive. 4. Primordial black holes, hypothetical black holes that could have formed soon after the Big Bang, with masses much smaller than stellar black holes. 4. They are still speculative, and haven't been observed directly. Hawking radiation. 1. Stephen Hawking predicted that black holes could emit a type of radiation due to quantum effects near the event horizon. 1. This is called Hawking radiation and suggests that black holes can lose mass over time and eventually evaporate. 1. This phenomenon is significant because it implies that black holes are not completely black and could slowly shrink over incredibly long timescales. Accretion disks and jets. 1. While black holes themselves don't emit light, the material falling into them often forms an accretion disk, a spinning disk of gas, dust, and other debris. 1. The material in the disk heats up due to friction, sometimes reaching millions of degrees and emitting X-rays and other high-energy radiation, making the black hole detectable indirectly. 2. Some black holes also produce relativistic jets, where matter is ejected at nearly the speed of light from the regions near the event horizon. 2. These jets can extend across vast distances and are often observed in galaxies hosting supermassive black holes. How are black holes detected? Since black holes themselves do not emit light, they are detected through their interaction with nearby matter and light. Some common methods of detection include: 1. Gravitational waves. The collision and merger of black holes produce ripples in spacetime, called gravitational waves, which were first detected in 2015. 1. This discovery provided direct evidence of black holes and a new way to observe them. 2. X-ray emission. As matter spirals into a black hole, it can emit intense X-rays, which telescopes can detect. 3. Orbital effects on nearby stars. In cases like the supermassive black hole at the center of our galaxy, scientists can observe the motion of stars orbiting around a seemingly invisible object, inferring the presence of a black hole based on the mass needed to exert such a strong gravitational pull. Black holes are still an area of active research and hold many unanswered questions, especially about their role in the universe, the nature of the singularity, and how they connect to the fundamental laws of physics.